Right, for the last question in this exercise, question 18, we've got a particle moving in a vertical plane when it collides with a smooth fixed horizontal wall. Now, just by reading that first sentence, we might think, oh, this is something completely new or completely different. So, what we have done so far is the wording of the questions where an object is moving in a smooth horizontal plane and it would collide with a small vertical wall. So this is what used to happen. So imagine this is my horizontal plane and this is my smooth vertical wall. So you've got a ball moving towards a smooth vertical plane. It would go there and it'll get bounced back. Now in this question, they have kind of slightly tweaked so the technique or the principles are still the same. This time you've got a ball that is moving on a smooth vertical plane, but this time the wall is horizontal. So you've got the wall as an horizontal object this time. That's not a laptop. I'm trying to make this look like a wall. So it's pretty much the same idea, nothing different. It's just that instead of a smooth vertical wall, this time we've got a horizontal wall. So everything remains the same. It's pretty much the same idea. So what we're going to do is we're going to use the same technique. So please don't be put off by the change in wording. Immediately before the collision, the angle between the direction of motion of P and the wall is alpha, where alpha is between 0 and 90. So I'm going to say this is my wall. Here comes my ball with an angle of alpha, which is an acute angle. And then immediately after the collision, the angle between the direction of motion and the wall is half alpha. So I know that the new angle is half alpha. Given that the coefficient of restitution between P and the wall is 0.4, we have to find out the value of alpha. So because I know both these angles, I would go back to the formula that connects both of them. Tan beta is equal to E times tan alpha. So I can say tan of half alpha is equal to my E is 0.4 and then 0.4 times tan of alpha. Now they like questions like these because there are no numbers. Most of them are variables, so we're trying to find what is the value of alpha. So there's very little to none information that will help us kind of resolve this or then do it that way. What we can do is I've got tan half alpha and I've got tan alpha here. So I would then try to use tan of a plus b formula. So I'm going to use tan of a plus b, which is tan a plus tan b over 1 minus tan a tan b. How I'm going to use is tan alpha, I'm going to split up that one as tan half alpha plus another half alpha. So I can then use this one as tan half alpha plus tan half alpha over 1 minus tan half alpha times tan alpha. That becomes tan squared half alpha. And now by using this, I have kind of sorted out an equation which is completely in terms of tan half alpha. So let's just bring all of those into the equation here. So I can say this is tan half alpha. In fact, let me make this even more easier. If I call tan half alpha as u, I can make my life much easier and then say this is equal to u is equal to 0.4 half alpha plus half alpha. This was in fact tan alpha, so tan alpha has in fact now become u plus u over 1 minus u squared. So I can say this is 2u over 1 minus u squared. So all we have to do now is we just have to focus on that equation. So let's just put these things aside now, and then let's do u is equal to 0.4 times 2u over 1 minus u squared. We can then go on to do u times 1 minus u squared equals 0.4 times 2u, which means I can, so I know that u is not equal to 0, so that is the reason why I can now get to cancel out the u. So that means I can now say 1 minus u squared is 0.8, or u squared is equal to 1 minus 0.8, which is 0.2. So u is equal to square root 0.2. I must say plus or minus square root 0.2. So what is u? U is tan of half alpha. Now we're going to bring in some of our trigonometry lessons, and then I can now say tan of half alpha is equal to plus or minus square root of 0.2. So I can say half alpha is, first possible option is it could be inverse tan of square root 0.2, and that is 24.09. That means alpha is 48.18 degrees. So that's 48.2 degrees to 3 significant figures. That is one possible option. Or if you remember ASTC, the half alpha could also be 180 plus 24.9. But the problem is we can't use that because I know alpha has to be in between 0 and 90 degrees. Another possible solution for this one is I can use the negative square root. So this is when I use the positive square root. Now if I use alpha is equal to the tan inverse of the negative square root 0.2, so that's shift tan inverse negative of 0.2, that is negative 24.9, which also doesn't really help us because that's in the second quadrant and it is not in between 0 and 90 degrees. However, if we do it now, I call it the cousin angle. So this one is in the negative 24.09. So its cousin is going to be here, which would be 180. Take away 24.09, and then even that one would come up to, so half alpha would come up to 155, which doesn't really help us making alpha in between 0 and 90. So the only value that kind of, so you can reject the negative square root, you can reject the 180 plus 24.09. So the 204.9, you can reject this angle. You can reject the negative square roots as well. So the only one that would help us is the 24.9. So alpha is 48.2. And that concludes exercise 5.